Good day everyone. For today we are going to discuss a new lesson. But before that, let's have a short recap of the discussion that we had last meeting. Infinite limit is a limit in which the function increases or decreases without bound as the value of the variable approaches an arbitrary number. In infinite limits, we only have two options for the limits. It's either positive infinity or negative infinity. If the function increases without bound as x approaches to a, the limit of the function is said to be positive infinity. On the other hand, if the function decreases without bound as x approaches to a, then the limit of the function is negative infinity. Always remember that when the one-sided limit does not exist, the function has an infinite limit. Let's take this as an example. The limit of the function x plus 2 over x minus 1 as x approaches 1 positive. By direct substitution method, the value of the function is 3 over 0, which only means that the right-hand limit does not exist. Therefore, the function has an infinite limit. Now let's have the process of solving infinite limits. Example number 1. Limit of the function as x approaches 1 positive. To solve for the infinite limits, we will evaluate the function using the values from the right of the approach value. Substitute the values to the function and compare the trend. Since we are using the values from the right, therefore, we are going to compare the value of the function from right to left. And based on the presentation, the value increases, therefore the limit of the function is positive infinity. Let's have the second example. Limit of the function as x approaches to negative. To evaluate the function, we will use the values from the left of the approach value. Solve the value of the function by substitution and compare the trend from left to right. And based on the presentation, the value of the function decreases, therefore the limit of the function is negative infinity. The other method in solving for the infinite limit is by examining the sign. Limit of the function as x approaches 1 positive infinity. This time, instead of using many values, we will just use one value from the right of the approach value 1. Substitute it to the function and examine the sign. We have positive over positive as the result, therefore the limit of the function is positive infinity. Next, let's have limit of the function as x approaches to negative. Using one value from the left of 2, we have 1.9. Substitute it to the function, evaluate the sign, and we have negative times positive, therefore the limit of the function is negative infinity. Now let's discuss limits at infinity. Limits at infinity are used to describe the behavior of the functions as the independent variable increases or decreases without bound. Let's differentiate limits at infinity and infinite limits. When we say infinite limits, the value of the function is the one that increases or decreases without bound, while in limits at infinity, the value of the variable is the one that increases or decreases without bound. We have two different forms in limits at infinity. First, we have limit of the function as x approaches positive infinity. This means that the values of the function is getting closer and closer to one and only one number as x becomes larger and larger. The second form is limit of the function as x approaches negative infinity, which means that the values of the function is getting closer and closer to one and only one number as x becomes smaller and smaller. Now, let's have the basics of limits at infinity. Taking the limit of the function as x approaches to positive infinity or negative infinity. As you can see in the given table, the value of the function f of x approaches to one and only one value, which is 0. Therefore, when we take the limit of a function in the form number over 0, as the variable approaches to positive infinity or negative infinity, the limit is said to be 0. Let's have example number 1. Limit of the function 2x plus 3 all over 4 minus x as x approaches positive infinity. To solve for the limit, we will be dividing both the numerator and the denominator of the function by the term in the denominator with the highest degree. The degree of the denominator is 1. Therefore, our divisor is x. Limit of the numerator 2x plus 3 divided by x all over the denominator 4 minus x over x. Next is to separate the terms. Limit of the first term of the numerator 2x over x plus the second term, which is 3 over x, all over the first term of the denominator 4 over x minus the second term x over x. Next is to simplify the terms that can be simplified. First, we have 2x over x. We can cancel out the common, which is x, so therefore what is left is 2. Plus, since 3 over x can no longer be simplified, so all we have to do is to copy 3 over x all over 4 over x. This can no longer be simplified, so copy. Then minus x over x is 1. Next is to solve for the limit term by term. So we have limit of 2 plus limit of 3 over x all over limit of 4 over x minus limit of 1. And applying the different laws of limits, we have limit of 2, which is 2, plus limit of a function in the form number over x, automatically that is 0, all over limit of the function in the form number over x, that's also 0, minus limit of 1, which is 1. Simplify, we have 2 plus 0, which is 2, over 0 minus 1, which is negative 1. And the limit of the function is negative 2. Example number 2. Limit of the function x squared plus 2x plus 1 all over x cubed plus 4 as x approaches negative infinity. So the first step is to divide both the numerator and the denominator by the term in the denominator having the highest degree. The degree of the denominator is 3. Therefore, our divisor is x cubed. Then we have to separate the terms. We have x squared as the first term in the numerator over x cubed plus the second term 2x over x cubed plus the last term 1 over x cubed all over the first term of the denominator x cubed over x cubed plus the second term 4 over x cubed. Next is to simplify the terms that can be simplified. Let's have the first term, x squared over x cubed. When we simplify that one, the answer is 1 over x plus the second term. We can cancel out 1x to both numerator and denominator, so the result is 2 over x squared plus 1 over x cubed, simply copy, all over x cubed over x cubed is 1 plus 4 over x cubed. Solve for the limit term by term. We have limit of 1 over x plus limit of 2 over x squared plus the limit of 1 over x cubed all over limit of 1 plus the limit of 4 over x cubed as x approaches negative infinity. Then solve for the limits. We have 0 plus 0 plus 0. Since all the functions in the numerator are in the form 1 or number over variable, then the limit is 0. All over limit of 1 is 1 plus limit of 4 over x cubed is 0. Simplify, we have 0 over 1 and the limit of the function is 0. Let's have example number 3. Limit of the function x to the fourth plus 1 all over x squared plus 3x as x approaches positive infinity. The degree of the denominator is 2. Therefore, our divisor is x squared. Dividing both the numerator and the denominator by x squared, we have x to the fourth plus 1 all over x squared over the denominator x squared plus 3x over x squared. Then separate the terms. We have x to the fourth over x squared plus the second term 1 over x squared all over the first term in the denominator x squared over x squared plus the second term 3x over x squared. And now let's simplify the terms that can be simplified. X to the fourth over x squared, when simplified, the answer is x squared. Plus, since it is already in the form number over variable, so all you have to do is to copy 1 over x squared. All over x squared over x squared is 1 plus 3x over x squared, cancel out 1x, we have 3 over x as the result. Next is to solve for the limit term by term. We have limit of x squared plus limit of 1 over x squared all over limit of 1 plus limit of 3 over x as x approaches positive infinity. Let's have limit of x squared as x approaches positive infinity. Take note that when a positive value is being squared, the value is positive. So therefore, the limit is positive infinity. Plus, limit of 1 over x squared. The function is in the form number over variable, therefore the limit is 0. All over, limit of 1 is 1. Plus limit of 3 over x in the form number over variable, the limit is 0. Simplify. When a positive value is being added to 0, the answer is positive. So, positive infinity. All over 1 plus 0 is 1. Simplifying positive of infinity over 1, the limit of the function is positive infinity. And let's have the shortcuts. The first shortcut, if the degree of the numerator is the same as the degree of the denominator, then the limit of the function can be computed based on the quotient of the two coefficients. For example, example number 1, limit of the function 2x plus 3 over 4 minus x as x approaches positive infinity. Now, let's have the shortcuts. If the degree of the numerator is the same as the degree of the denominator, then we will just divide the coefficients of the term having the highest degree. So, in example number 1, that is 2 divided by negative 1, the limit is negative 2. 8 divided by negative 2, the limit is negative 4. Next, if the degree of the numerator is smaller than the degree of the denominator, then the limit is 0. And if the degree of the denominator is bigger than the degree of the denominator, the limit is infinity. It's either positive infinity or negative infinity depending on the solution. And that's it for our discussion for today.